been pondering or something a reader asks. Often it's inspired by an article from our parent organization, Annual Reviews, the nonprofit publisher of over 1,000 scholarly reviews every year on everything from microbiology to sociology to particle physics. After making some important decisions, we assigned the story to one of our seasoned science journalists, many of whom originally trained as scientists. The writer interviews multiple experts on the topic and carefully shapes the story. Next comes edits, asking questions, rearranging information, smoothing, fiddling and pruning. Back and forth from editor to writer it goes until everything's there and in the right place. A fact checker then scrupulously verifies every word, from the color of a scientist's armchair to the mass of a subatomic particle. After any needed changes, it's off to the copy editor, who flags issues with grammar, tone, or flow, ensures that the style is consistent, and crafts a compelling headline. All the while, our art director is researching, designing, and commissioning the infographics, photos, and illustrations that give a story visual sizzle. Then it's publication time. With a final check, the digital producer compiles all these elements and brings the story online. All this work ensures that every story has the Knowable stamp: smart, trustworthy, timely, and compelling. And it doesn't end there. Our stories are free for everyone to read, share, republish, and enjoy, bringing fact-based science stories to curious minds all around the world. To make this all happen, we need your support. Head to knowablemagazine.org/donate and become a sustaining donor today.
Hello everyone, and a very warm welcome to this event on Keys to Successful Aging. I am Richard Gallagher from Annual Reviews. This is the annual Zare Science Forum, co-sponsored by Knowable magazine. The event is named in honor of Professor Richard Zare of Stanford University. Dick is a distinguished researcher in physical and analytical chemistry. He's an acclaimed teacher and mentor, a renowned science administrator, and an all-around good guy. He was chairperson of the board of directors of Annual Reviews for 23 years, and he continues to serve as a board member to this day. Thank you, Dick, and thank you to all of our wonderful board members. Before I introduce the talent, a word about the format today. This is a series of 3 short interviews that explore different aspects of successful aging. Person A interviews person B, B interviews C, and C interviews A. We've set aside time for questions at the end, and you're welcome to submit these throughout and to use the chat function to talk to one another during the event. Before I introduce the discussants, I see that the word cognition comes up each time. Cognition simply refers to intellectual activity such as thinking, reasoning, or remembering. So cognitive impairment is a reduction in these functions. Daniel Levitin is a neuroscientist and a cognitive psychologist. He has written best-selling books, including one titled Successful Aging. Dan is the founding Dean of Arts and Humanities at the Minerva Schools at Keck Graduate Institute in San Francisco, and he's also Professor Emeritus of Psychology and Neuroscience at McGill University in Montreal. Susan Turk-Charles studies emotional processes across the adult lifespan at the University of California, Irvine's School of Social Ecology, where she is Professor of Psychological Science and Nursing Science. Susan explores how subjective experience varies throughout life, and she relates these differences to changes in cognitive processes. Saul Vaileda's research interest is in impairment of regeneration and cognition in the aging brain and how this impairment can be reversed. He is Assistant Professor of Anatomy at the University of California, San Francisco School of Medicine. Saul's goal is to identify cells and molecules that can promote rejuvenation of the aging brain. I hope, like me, you're really looking forward to these discussions. The first pairing is Saul interviewing Dan. So take it away, Saul.
Thank you so much, Richard, for that introduction. Really looking forward to this conversation. Hi, Dan. Good to see you again.
Nice to see
Yeah,
you,
so I'm
Saul.
excited. I'm very excited to ask these questions and have a little chat with you about some of them. So let's go ahead and start. So we all tend to think that older age, right, is this time of decline and decay. But you've argued that isn't necessarily true. So I'm really interested in what exactly is your view?
Well, I think it's not just my view, it's the view from science. I think that we're dealing culturally with an outdated narrative. Yes, old age used to be a time of decline, but we're living longer, we're living healthier. We've eradicated most diseases that used to kill us before the age of 5, let alone before the age of 30. Back in 1905, life expectancy was shorter and life was harder. So I think the new reality based on neuroscience, psychology, gerontology is that 80 really is the new 60. Now, it's true, we do see some gradual slowing with every decade after 40. Thought processes slow down. And there are neurostructural changes, as you know, that cause things not to work quite as well as they used to. But to say that old age is a time of decline or irrelevance, I think is unfair and untrue to the science. Memory doesn't necessarily have to go. I mean, in most of us, we can retain robust memories into our 80s and 90s, and other cognitive functions. And I think the key point here, Saul, is that there are things we can do at any age to tilt the balance, to give us a fighting chance against the natural physiological processes of aging.
So you bring up a really important point, right? Which is, you said in 1905 versus now, right? Our lifespan is different. This idea of mortality, of course, is different. At least, for me, I often think about, that decline and that decay. I think I have it associated a little bit with mortality, probably from my own perspective. So why do you think so many of us, hold this view of decay and decline that isn't necessarily now true in the context of modern medicine and how old we're living now?
Well, we hold a lot of views that are not true in terms of modern science and medicine. That's a systemic problem, particularly in the last few years. An increasing number of people say they don't know who to trust, and you can't trust the experts because they keep changing their minds. But I think, without getting into the sociopolitical part of false belief, I think it's that,
we can go there a little bit.
well, you're better to talk about this than I, but I think the situation is that increasingly people don't trust science and scientists because from their perspective, we change our minds all the time. First, they tell us to eat beef, and then they tell us not to, and then fat is good, and then fat's not good. And the reality is the average person doesn't know that science is an iterative and self-correcting process. We take in new evidence as it becomes available, and we adjust our views. And so the story changes. Doesn't mean we don't know what we're talking about. We're basing it on the available evidence. But I think the crux of the matter is that we've got these outdated societal narratives from the media, from cartoons, and in any sitcom that you were to watch, the old person is usually the brunt of the joke, right? We're now at a time of reckoning in our society where we're facing head on a lot of the isms that come from prejudice and bias, racism, genderism, and really ageism is still with us. It's not something that's talked about. But we make jokes about old people. They are the doddering old ones that cause a laugh, and that's something that we can change.
I love how you said, right, it's science and what we do is self-corrective. I think that's a wonderful way of thinking about things. I think I've gotten a lot of questions over COVID and vaccinations and people, we're as the data comes in, we're adjusting, right, our hypotheses and our expectations all the time. And I think this idea of aging and even, aging research is often so linked, I think, to the diseases that we think of as, age. I think a lot of us maybe think one is the other. And I'm wondering if you think that plays a role in sort of this myth that we have, like you said, of that cartoon, the older person, that's the joke of it, or why you think, why do you think that failing memory that we think is such a myth, I guess?
Yeah, well, it's interesting. You were talking about updating hypotheses and gathering data. I was just talking to your colleague Jay Levy recently at UCSF, who discovered the HIV virus. And this whole business with the coronavirus has been one of updating our understanding, and we still are.
Absolutely. Yeah.
It's often a long process. I think that we do confound. There are many people who think of aging as a disease and that it's curable. Others think of it as a natural process, and maybe it isn't curable, but some of the symptomatology, some of the side effects that we see of aging, like weak bones or loss of a sense of balance, slowing, maybe those things are correctable. That's all on the horizon, and I think it's important to acknowledge that we haven't had the opportunity to study aging until recently because people didn't live long enough.
Yeah.
And it also wasn't considered a priority. Why should we as a society spend money studying 80 to 100-year-olds? How many people is that going to help? The reasoning might go with the granting agency, as opposed to studying younger people.
No, that's a really great point. Something I've been thinking a lot lately is just in the news. You get all this news from census and everything, and birth rates are down. In the United States, they've been down for a long time. In Japan, for example, and we know this elderly population is coming. And I think for a lot of people, it's this scary idea. And I love that from the perspective that you're coming from, it's not necessarily as scary a concept as we might think. I think people think, oh my goodness, there's going to be this huge population and it's just decay, like we said. And I've learning more about sort of a different perspective coming into it. I think that there are a lot of good things that we may not be looking into that comes with that old sort of age that comes with it. One of the things I found really surprising in learning more and going through what you've written is sort of the contribution or the role that personality factors play in sort of how we age. And I'm a biologist, so I'm reductionist, and I think of things as sort of controlled and almost try and take away certain aspects such as personality from the equation, and that seems to be not the case. And I just want to know if you can elaborate a little bit on the role that plays.
Well, I consider myself a reductionist too. I mean, the fundamental tenet of neuroscience, as I practice it and understand it, is that all of our thoughts and hopes and desires, feelings and experiences are ultimately the products of a biological set of functions in the brain, that they have a physical basis. We call it materialism, that the material of the brain gives rise to all of this. So personality may seem like this squishy thing. Some people are more generous than others. Some are more outgoing, but these have a genetic basis, a biological basis, and a basis in experience. The idea that genetics and brain development and environment interact is profound and now I think widely accepted. And so I think the key argument that I've been trying to make for the last few years is that, yes, genetics will provide a kind of predisposition towards being a certain way. I mean, in your body, the genetics can provide a predisposition towards being able to beat cancer or a propensity to get it, or heart disease, as well as personality factors like conscientiousness and curiosity and resilience. But in many cases, those personality factors, which have a genetic origin, The genes control as little as 7% of the variability, and rarely more than 50% of the variability in outcomes, meaning there's a lot of wiggle room there for us to try and modify our lifestyles to give us a fighting chance to do better.
So, kind of building on that a little bit, just with, I think, COVID, with vaccine rollouts, with just looking at how a pandemic affects an entire sort of society, it reminds me that not all aspects of society are sort of treated equally or impacted equally, right? There's different cultures, for example, socioeconomic factors now that become almost a part of our culture in the American system. For example, we have the educated, we have people that are well off, we have people that are poor, people that are less educated. And I'm wondering how you think of that, where you place those both cultural and that affects also personality responses in the context of aging. So, is it something that you think it's a little bit different depending on sort of where you start from? Is it one global sort of one personality factor that really is like the most important? Where do you see this?
Well, you raise a lot of really crucial issues here. I'll just try to tackle two of them. There is a single personality factor that has a genetic basis that more than anything else predicts how well we're going to do at any phase of life, how happy we'll be, how healthy we'll be, how long we'll live. And that single factor is conscientiousness, which refers to a cluster of traits such as stick-to-itiveness and reliability and dependability, following rules, conscientious kids don't get hit by a bus because they don't cross against the light. Conscientious adults don't end up in prison, which is bad for your health. I mean, there are mistakes made in some cases, but I'm talking statistically here.
Yeah.
You can get hit by a bus when you have the light, but I'm setting that aside. And so too much conscientiousness isn't good either. It can lead to obsessive compulsive disorders. But there's a kind of Aristotelian golden mean here, where the ideal amount of conscientiousness contributes to a happy, long, and productive life. But as you point out, conscientiousness and other traits are unevenly distributed throughout the population. And due to socioeconomic conditions, not everyone in the population has equal access to being able to change themselves or act conscientiously. The biggest disparity is in healthcare in our country, where whether you're conscientious or not, if you're rich, you can afford better care than if you're poor. And the most conscientious poor person has difficulty accessing quality medical care. And so we can talk all we want about this lofty ideal of, I'm going to go out and become more conscientious. And tragically, that applies to a relatively thin slice of us in the world. There are some people who, I know people here in the US who are working 2 and 3 jobs. They're overweight. They don't have time to exercise. They don't have time to eat well. They're on the road. They're traveling. They've got to get fast food. They're trying to raise 2 kids as a single parent. This stuff, this is hard to pull yourself out of that and say, I'm going to get healthy now. I'm going to lose some weight with all this other stuff going on. And I'm just using that as one example.
No, that's a really, really good point. I think I had one more question to ask, but I think we might be out of time. I'll come back to it though during the Q&A if that's okay. I know we have it, so first in line for me.
Well, thank you, Saul and Susan. I've been so looking forward to talking to you. You and I work in different areas and yet overlapping areas, and so I'm interested to learn more about your research and your views on this. To begin with, are there any life domains that get better as we age?
Yes, and I'm I'm happy to talk about this in addition to what you mentioned about remaining vibrant and cognitively active and engaged. I study two domains where we find age-related stability and often improvement across adulthood. And that first domain is in the area of our social relationships. So those arguments, the contention that people often have in their daily lives, that decreases with age. And people often report greater satisfaction with their relationships over time. So we see continual improvement in the emotional meaningfulness and satisfaction in relationships. A second domain is our emotional experiences, those emotions we experience on a daily basis. So older adults often report less distress than younger adults. They certainly have been during this time of the pandemic and in all the times before. And we also see that older adults regulate their emotions as effectively and sometimes better than younger adults.
So my image of the cantankerous old coot down the corner who's yelling at people, that's an anomaly, I suppose, because statistically people are regulating their emotions.
Yes, and whenever I have a talk, I always get that hand raised in the back of the room. It says, "Let me tell you about my grandfather or my uncle." I mean, there's always that one person to dispel all the research that I've amassed across decades, and that's where the personality context comes into play that you talk about. There's certain personality constellations that we've studied. So, for example, people who are high neuroticism, so that tendency to feel high levels of depression and anxiety and to question your self-worth, that personality trait, we find a lot of these age-related improvements in our emotion regulation, our emotional experiences, we often don't see these age-related benefits in people with certain personalities, such as those with high neuroticism. So not 100% of people get better with age, but the majority do.
Getting back to this earlier thing that you said about how older adults experience less contentious relationships and they experience better relationships. I'm now north of 60. I'm noticing that. I know what it is, I think, that's helped me in that domain, but I'm wondering what the science says. Is it that older adults lose patience with the so-called friends in their lives who make them miserable and they weed them out? Or is it that older adults are more grateful and feeling more gratitude for the friends they do have? Or are there other factors?
Oh, there's quite a few factors. And so that's a wonderful question. So some of the ones we've studied and found is that as you grow older, that social networks get smaller. And it's not that they're getting smaller as far as close friends and family members, but we see that older adults have fewer of those peripheral people that you don't know very well. And we think that's a proactive strategy on the part of older adults, even though they don't really consciously realize they're doing it all the time, but they are choosing to spend time with the people that mean the most to them, who are the closest to them. They prefer to spend time with their close friends to a higher degree than maybe younger people who might, who like spending time with their close friends and family, don't get me wrong, but also want to meet that person and that stranger. Who is that person that we don't know? Let's get to know them. Whereas older adults, if you ask them, would you like to interact with a stranger or would you like to have coffee with your close friend? They are more likely to say, I'd like to be with my close friend. And we know that interacting with those people that you love and feel closest to also helps your emotional well-being.
This goes by the name, if I'm not mistaken, this is called socio-emotional selectivity theory.
Yes, socio-emotional selectivity theory that Laura Carstensen coined so many years ago that we've been studying. Also, older adults are more likely to, when they're having an argument with a friend or family member or even a stranger, they're more likely to disengage from that argument. They will report that they do that, and they'll report that they're fine doing that. They realize when something's not going to be solved or what's the point of arguing. and they do this more quickly than younger adults.
You know, just as a quick diversion, you and I were both at Stanford as undergrads and later as postdocs. I think we overlapped. One of the things I remember about the Stanford Psych Department was how many older people were still working full time, whether it was Al Bandura or Ewart Thomas, many people who were beyond nominal retirement age. I wonder if that influenced you, or what aspects of being in the department in those heady times influenced the course of your work.
They were indeed some wonderful times. Al Hastorf and Al Bandura and so many wonderful, Gordon Bauer, who is close to retirement and continued decades after. And many academic departments around the country, you see people retiring very late in life. And I think it has to do with just the joy of scientific discovery that you and Saul were talking about earlier, that science is always new, it's always unfolding, it's we're always making these discoveries. And that's one thing that I enjoyed so much about being there and being among scientists, is they want to know, what is that answer? You know, that joy of discovery, and it still is there and remains vibrant, and you don't want to stop that. And at Stanford, there definitely was, I think, that the desire to find what science is telling us, more so than the desire to be proven right or the desire to hold fast to old beliefs. It was the desire to see what's coming next, and that's what kept people so engaged for so long, I think.
Richard. I was just thinking of my own experience at McGill, where Brenda Milner worked came into the MNI until she was 99. And Peter Milner, who was in my department well into his 90s, from Milner and Olds, the old pleasure center studies in the 50s, he was still going strong in 2010. And it was great to see him and learn from him. But moving back to the present, the pandemic has created persistent stress and trauma. I've come to believe that maybe the entire country, if not the world, are all suffering from some sort of low-grade chronic depression or traumatic stress. And of course, older adults have been disproportionately affected by the physical effects of the disease and by the isolation, particularly older adults who are in group living situations or care homes of one kind or another. What have you learned about the mental health effects, and what do you predict will happen over the coming years?
Yes, it's the pandemic, you're absolutely right, has been devastating, and the health effects have been disproportionately shouldered by older adults, and with each decade of life that we see the effects being so much worse. For mental health, actually the reverse is true. For each decade of life, the reports of the mental health wear and tear of not only having the health problems around, but the social distancing associated with that have been really borne on the shoulders of the younger adults. We see rates of mental health and rates of distress, moderate and severe distress, are greater for people of all ages. So no one has escaped. But for people in their 20s, for example, it's 4 times the rates of severe distress than we see among people who are over 60. So people who are most distressed 2 months into the pandemic were those who had children under 18 at home. And so these young families, these young adults have borne the mental health distress of not only COVID-19, but all of the economic and social fallouts of the pandemic. So also those who live alone have been very socially isolated, but we also see that living alone is harder for younger adults than it is for older adults during this time.
It's going to be a problem for a while. It's the solutions are. I mean, even once we're more or less back to normal, I think the psychological effects are going to play out for some time. But there's something else I wanted to explore. I love this distinction that I just recently learned about between lifespan and health span. Can you walk us through that?
Yes, and that's something that that all of us know well, but I think the lay people in our society are now focusing more on, and I'm thrilled to see this. Nowadays, science has told us that, at least in the United States, over almost half of children born today will celebrate their 104th birthday. And we see this in rich countries. It's even greater in places like Japan, where it's 107th birthday. And so we see these incredible lifespans ahead of us. And so lifespan, which is the focus of how old we will live, has now given way to a lot of scientists, and that's why your book was so perfect to address this, which is health span. So let's think of ways and study how to live this very long lifespan as healthy as we can. And health span are the number of very healthy years that we have. Now, health. What is health in old age? What is successful aging or healthy aging? We often define that as having high levels of cognitive functioning, so our memory is sharp, our problem solving remains sharp, our thinking does. Emotional well-being, so experiencing a lot of high levels of happiness and contentment and joy, and lower levels of anger and depression and anxiety, and also physical functioning that allows us to be healthy and pain and not experience a lot of pain, and be able to carry out the activities that make us happy and active and engaged.
Well, if we're all going to live to 107, and we've got children and grandchildren, great-grandchildren, great-great-grandchildren, I'm going to need a bigger Thanksgiving table, that's for sure.
All right. So, Saul, I am now very excited to be talking to you, because you are going to tell us about the molecules behind living to be older and older. And coming from the social science world, tell me, what was it about molecular biology that excited you and directed you to your current interest, and particularly studying aging?
Yeah, no, thanks for that. So I guess I'm almost gonna like take off from where you ended, which is this idea of lifespan and health span. When I was just starting out as a graduate student, there were these amazing kind of studies in animal organisms where they started manipulating individual genes, and you could make these animals live longer. It started first in things like worms and then in mice, but we started understanding that just tinkering with a molecule or with a protein or with a gene could somehow extend it. Now, when I was growing up, I was actually not, I never thought about doing research in aging. I loved development. I loved everything about the way that we come to be, how, our personalities are formed, how our brain develops. And I thought it was just such an interesting approach, going from just a cell into like a human. But I started to see a lot of parallels with aging in terms of there's some control to it, there's some genetics to it. But it was a really sort of weird kind of field in that we were never really, almost intended to live this long back, in the day, hunter-gatherers live 2025. Dan said it really well. Look at just 1905 versus now. And then what you said, now that, these children can look forward to 104. So where does kind of the biology of aging fit into all this? If this is a new thing that we're living so long, is there some sort of control? Is it something like development where there's some exquisite interplay between cells and molecules that form, your brain or your nose or your bone? Is that continuing on? Are those processes still happening, which is what's maintaining function, which is what's promoting cognition? So I got into it kind of from this fascination of development, realizing there's these parallels between regulation of lifespan and development, and now really thinking about, well, if we're going to live 104, I want to be, as sharp as possible. Can we leverage, that sort of idea behind development into old age? What can we do?
And that's, I'm so glad you talked about that segues into my next question, because we hear about how people can extend the lifespan of a worm like twice as long, and that's amazing, but we want to have a cognitive ability to function a little higher than that worm. And so what can the biology of aging tell us about cognitive integrity, so maintaining that high level of cognitive functioning as long as we can?
Yeah, the brain, I mean, we're all fascinated by the brain, right? That's why we were asked to talk today. I have learned that the brain seems so almost unique compared to some of the other, tissues or organs in our body, in that even when we're looking at just animal models, even if you look at a, 2.5-year-old mouse, which is the equivalent of, someone in probably close to their 90s, past their 90s, we have this huge spread in terms of our ability to learn and remember. We have a portion of those animals that will just act as if they're still like 25. I mean, they just naturally are aging and their function stays sharp. And then we have a proportion of those animals that do show some decline. And if you look over time, it may be because, they had an injury, or, there may be other problems with them or disease that caused that. But when I look at that proportion of those animals that are just as sharp as before, that tells me that there's a lot of plasticity still in the old brain, that there's a lot of resilience. It brings me back to this idea of development. Something is happening in the brain, regardless of how old that brain is, that can still keep those connections, that can still sort of maintain itself sharp. And what we're learning now, there's this new concept of the biology of aging, not disease, but really just this process, right, of getting older. And we're focusing now more on this idea of health span. And people are starting to think that the way your molecules and your cells are changing, the way the cells interact with each other, the way the organs interact with each other, promote sort of some of what we think the aging phenotypes are. Let's say gray hair or wrinkles that we're all going to see. That's a combination of a lot of different mechanisms at play. But somehow there are aspects of the brain that are able to counteract that. So right now, that's a big interest in the field, is understanding sort of the health span of the brain, because it seems like the brain ages almost a little bit different than some of the other things. Like I said, you get gray hair, your stem cells in your your hair stem cells are weakening. You get gray hair, you lose your hair. Same thing, elasticity in your skin. But somehow something about the brain itself seems very unique and special. And we're trying to figure out, what is it? Is it molecules? Is it the way that your cells are communicating? Are they getting signals from the rest of your body that are telling your brain, hey, promote cognitive function at all costs? We're still learning about that. But I think there's a lot to sort of explore there.
So what do you think they are? I mean, what is it that might be able to help us maintain cognitive functioning, or even reverse if we start noticing decline? What on the molecular level or the cellular level is going on that you think will help us?
Yeah, it's interesting. I teach a class to these to graduate students and also to medical students, where we talk about the biology of aging. And I start the class by saying, what is aging? And people take pause with that question. What is aging? And then they'll oftentimes say, well, I know it when I see it. Or they'll say, well, there's like gray hair, or there's, injury or inflammation comes up a lot. And then I tell them, okay, well, why don't we try and reduce this a little bit? Can you give me hallmarks of aging then? Maybe we're not sure about the whole aging process, but what about hallmarks of aging? And it took, these biologists of aging researchers a long time to even define a series of hallmarks at cellular level. We have them now. And some of these are going to be kind of like buzzwords. Some things we think about are like telomeres. So the little caps of your chromosomes that shorten as you get older. We think telomeres might be important. We have things like stem cells. We think, stem cells over time, they just get a little bit more quiet. They get quiescent. Something like your, gray hair, loss of hair. Maybe your stem cells on, the top of your head just aren't working as well. So you're going to get, sort of this balding. There's other things like senescence, which is basically when a cell just kind of flattens out and just starts secreting, inflammatory molecules. Another hallmark we came up with was the way the cells communicate with each other. The best sort of way to think about that is inflammation, right? Inflammation is your immune cells communicating to your whole body, especially things like, infection of a virus. We need that immune system but it is different as we get older. So we're thinking collectively all of these things, whether it be DNA damage, whether it be senescence, whether it be stem cells. We're thinking about it holistically now in terms of, okay, all of these changes promote aging in individual tissues. Now, the idea now is, well, what if we can somehow block those changes, or if we can maintain youth? What happens if we find a way of just activating your stem cells in your body? If we can maintain your stem cells going the whole time, right? Will we no longer have gray hair? Will we not have wrinkles? Will we have much better improvement? Let's say, when you're running and maybe, you have an injury to your muscle, will it just recover much faster? Will we be able to suppress inflammation? So that's where the research is right now, trying to figure out which hallmarks of aging can we target? And if we can target enough of them, can we maintain sort of a youthful state? Could we actually take an 80-year-old and it looks more like a 30-year-old? Is that actually possible? So not lifespan, but like you said, health span. Can we keep things healthier longer?
So some of us are aging, closer to those times when dementia starts becoming a real thought. So we only see it in about 5% of the population under 65, but as we know in this law of doubling, and 70-year-olds are hitting 10%, and so it's something that that we think a lot about. And so when we think about studies like yours, we think, how can it help us against things like dementia or neurodegenerative diseases such as dementia? Now, we know there's been millions and hundreds of millions of dollars poured into develop therapies, and they haven't always been successful. In fact, we don't have a successful treatment for the declines that we are seeing. And I'm wondering what your thoughts are about these targeting, this geroscience that you're talking about, these mechanisms of aging, maybe the metformin, the interventions that we're seeing in these trials. What do you think of those and how they might help us?
Yeah, it's interesting because there are now, I think it's becoming more known, there are trials that are trying to, some people say extend life, some people are like, okay, rejuvenation. They get a lot of buzz. There was the red wine study, and in red wine there's resveratrol, and what does that do? Now there's sort of these antifungal drugs like metformin that are known to be really, really beneficial in, again, animal models. Can they do something in humans? There's still this idea of like dementia or disease like Alzheimer's, and then there's the idea of aging. And some people think, oh, it's one thing, like you age and eventually you get the disease. Some people think, no, really, there's a clear distinction between the disease and the aging process. And this is still, when we go to these conferences, these are still points of contention and sort of discussion. What I do know is that there is a link, right? As we get older, 80, 90, there is an increased sort of prevalence of these diseases. So we can't sort of tangle the two, I think. But the idea is our body, like you said, before 55, if we look at 40, I mean, like, it's a small fraction of the people that have dementia. So that means that even with people that have genetic predispositions to them, they still don't show those signs when they're young. So the idea is something about youth staying, cognitively healthy, resilient, can counteract some of those effects. And the idea is, what can we do to maintain that as long as possible? We've tried a lot of things. They've targeted A beta for Alzheimer's. They've done antibodies, and it just doesn't seem to work. So this new idea is, well, why don't we just try and maintain youthfulness? And a lot of it, right? I mean, there's social things we can do. There's the interventions like exercise. Some people think caloric restriction is also really beneficial. So other things that we can do that we know are targeting those hallmarks of aging. And can we just maintain function for as long as possible as an alternative, let's say, to finding that sort of drug that takes away, the plaques from your brain? So that's sort of an idea. And I think some of these trials, like the ones on metformin, the ones that are pursuing some of these molecules that have been identified, I think that's what they're trying to do. I think they're trying to catch it before it starts and just maintain natural physiology. I think especially in any space where there's no answers, why not try different things, right? Or why not try different avenues? For me personally, right now we're studying exercise in my lab. Exercise is great. It's been shown to be so beneficial, even in patients. It's conserved, even when we look at it in little animals like our mice or our rats. It's just beneficial. They have enhancements in cognition even when you're young. Now, I was thinking about, what Dan said. He said, I know someone that works 2 jobs and they overeat and they're just stressed, and that's just not going to be conducive to the healthiest of aging, right? To maintain that resilience at a cognitive level. And what we're trying to do is we're trying to understand, what is it about your body that's changing when you're exercising? What's so good about it? Is it hormones? Is it things in your blood? Is it your muscle? Is it, the way your neurons are firing? And we're trying to distill it down to molecules. Once you get molecules, you can make therapeutics. You can make things that can actually be injected or sort of, ingested as well. So right now we're trying to figure out, is there a way of distilling that benefit of something like exercise down to something that can be introduced? And that's sort of, in our animal studies, what we've done, which is we identified some blood factors that just go up. They're liver factors that go up naturally when you exercise. And then when you give it to an older animal, you can actually enhance, you can boost cognition, even in the context of some of these disease models. So that's sort of what we're pursuing, is taking interventions that we know are beneficial and trying to give that benefit to a group of people that won't be able to do it, either because they're frail, because lifestyle just, their life just doesn't allow it, but we know they can benefit from it. And that's sort of where we're targeting health span. We're trying to take known health span interventions and be able to apply it to people that just will not be able to do the intervention themselves.
So my last question for you, since I know our time is running out for the 2 of us together, how soon do you think these interventions will become commonplace, that I'll be able to go to my doctor and get an intervention of what you're doing in the lab?
It's such a good question. My answer today will be different than my answer would have been last October. How fast we managed to come up with a vaccine to COVID that was based on brand new technology around mRNA that completely blew scientists' minds, because it normally takes years to get there. Yet somehow, by putting resources, opening borders, facilitating communication, interaction, crosstalk, I mean, we transformed that. So then my feeling right now is, if we just talk together a little bit more. So if we have, like, the molecular biologists talking to the people that are actually talking to that are geriatricians or psychologists, and we understand more about what is the need. What do we mean by saying, I want a drug that maintains, X? I think from what I stand, and I'm doing these preclinical studies in a mouse, I mean, I wasn't even thinking about personality traits and factors the way that Dan is, because I'm looking at a little, mouse that I don't really attribute too much of that for. So I now think, within the next 10 years, I think it's absolutely feasible to do something to improve cognition, at least to maybe slow down, the onset of something like dementia and Alzheimer's. But I think that because of what I saw as possible through things like this mRNA vaccine. So that's changed my perspective on sort of speed.
Thank you.
Great. Well, thanks very much, all 3 of you, for a fascinating discussion. We've had a number of questions, and I'd like to get right into them. The first one is, drawing on all of your research experience and all of your reading, can you provide us with a kind of hit list of do's and don'ts? So what are the keys to successful aging? What are you doing? Let's say, what should someone in late middle age be doing right now and not doing right now? And what should someone who is already old, I don't know what age, 70, let's say, what should they be doing and what should they not be doing?
So I'll go ahead and start. I think it's wonderful to have that list, and there are many. I know that Saul and Daniel will have additions to this, but they're the usual items that have become very well known in the popular literature now. So sleep, we know sleep is related to our physical, our cognitive, our emotion regulation. We need our sleep, and we need high quality sleep. We need to exercise. Exercise is vitally important to our cognition, also our emotional regulation, and our physical health. And we need to eat a healthy diet. I just want to add 2 more, and I'll let others add things. Or 3 more. So social relationships, having strong social relationships predict who's going to die, as well as knowing their cholesterol levels or their smoking history. It is huge. And yet people don't often include that on their list of health behaviors. But your friends are as important as predictive in our research as cholesterol levels. Another one is the emotions that you have every single day, that response to a work deadline or an argument with a friend, how much you react to that. We see that predicts whether the incident of chronic condition and mental health disorders 10 years later. So when you think about regulating your emotions, it's not, it's these small things, these small bumps that every day cause wear and tear, and they accumulate over time. But just one more, and then I'll just learning novelty seeking to stimulate the hippocampus and get the mind going and your memory. So learning, being exposed to novel activities and learning these activities. And in our research, we found that if you engage in a varied activities, so a lot of different activities every day, we find that is related to your cognitive functioning and predictive 10 years later. So other?
Ben? Thanks.
It's said, because I agree with them, but I don't think I would have said them as well. I'll just drill down on a couple which are with respect to sleep. We've seen now many cases of Alzheimer's that was misdiagnosed, and it was just sleep deprivation. So particularly among older adults after a certain age, whatever that age is, it's different for everybody. But it becomes more difficult to get the sleep you need because the suprachiasmatic nucleus, the part of the brain that's regulating your sleep-wake cycles, doesn't function as well. Melatonin signaling is not as good. There are a number of reasons. Those are just two. Doesn't mean you need less sleep. And one night of impaired sleep, particularly over the age of 60 or 70, can disrupt your memory function for a couple of weeks, because one of the primary functions of sleep, besides cellular housekeeping, cellular cleaning, is to help encode memories. The other thing I just want to drill down on quickly is that, yes, exercise is important, but many of us find the notion of exercise off-putting or intimidating. And really, based on what our colleague at UC Santa Barbara, Scott Grafton, writes in his book, Physical Intelligence, exercise is perhaps the imprisoned corollary of movement. Just getting up off the couch and moving. And as Susan says, exploring in general helps the hippocampus, which improves memory. Exploring the environment is very important. So even if you don't exercise, just get out, walk around, especially in nature, is good advice at any age. And in wheelchairs, people who do this in wheelchairs show great benefits too.
So maybe just to add one little thing as to the why, maybe, where, from our perspective in sort of the molecular biology, we're starting to understand the why. For example, sleep. Sleep is so big. Even in the animal models, if you disrupt sleep, you decrease lifespan. And in the brain, why is that? We're finding out now that your blood-brain barrier, what sort of restricts the rest of your body from your brain, it actually opens up a little bit when you sleep, and it actually gets rid of some of the trash, right? Some of the protein aggregates that are in there are released into your blood when you sleep. And we know that because we've been able to manipulate these things in animal models. That's one of the main reasons. You're clearing your brain at night. Social isolation, we see the same thing in these little animal models. Why? When you socially isolate them, again, you shorten their lifespan. And what ends up happening is you increase all these stress hormones that hyperactivate your immune system. It's almost as if you were sick, but not because you did something, because you're isolated. So I think, the social isolation, new novel environments, and things like sleep, we understand now why. We understand exactly what we're impacting that's causing the benefit. So I think those are fantastic.
Just a final quick question on this before we move on. Linda Rudnick asks about sufficient hydration. Obviously very important. And she asks about water-only fasting and if you know whether that has any effect on brain health. I think at some other point someone asked about the positive and negative impacts of cannabis. If you want to comment on any other of that kind of thing, you can avoid that if you'd like to.
I'm happy to jump in on the fasting, and I'll leave the cannabis question to others. There's mixed evidence on fasting. We've spoken in this hour about caloric restriction. It certainly works with C. elegans, the worm. It works with mice. But, you know, I was talking to a director at the NIH in doing the research for my book, Successful Aging, and he said, you know, the problem is that 95% of the stuff that works in mice and really should work for humans just doesn't work for humans. So we don't know. It doesn't seem to hurt. It doesn't seem to matter how you do your intermittent fasting, whether you just skip dinner every day or skip an entire meal once a week, or just go on a water fast for every day, or every day a week or something like that. None of that seems to matter yet. We don't know. Science is iterative. We hope to know. But the crucial thing here about hydration shouldn't be lost. Hydration is a serious stressor on the body, and just drinking more water when you're hydrated typically doesn't help because your cells aren't ready to receive the water, which is why we have things like Gatorade and oral rehydration solutions that bring in the electrolytes and the salts that your body needs to actually use the water. There are a number of hospital cases where somebody was dehydrated and they kept drinking and drinking and drinking water, and it actually damaged the physiology because the water wasn't getting in. There's a medical term for being overwatered. I forget what it is.
Well, let me move on because we only have another couple of minutes. And, you know, as we live longer, I wanted to ask you whether the societal role of the elderly should change and is changing. And maybe there's something to learn from other cultures here. I mean, we have this, you talked about academics continuing to work into their old age, but what about the rest of us? I mean, where do we find meaning, and how important is it, is meaningful contribution to successful old age?
And that's a wonderful question. And I think that as healthier people are living into their 80s and 90s, we will see their roles changing and growing. We have the oldest president that we've ever had in the United States serving the country. So we are seeing these wonderful, healthy examples. I think that it will also make the 20-year-olds and 30-year-olds realize, with such a long life ahead of them, that they also have freedom. So it creates freedom at every decade of life to realize we have this time, we can really use it and be productive at every decade in our lives. So as far as the physical aspect of that, I don't know. Dan,
I think one really interesting that I've been seeing, especially here, at least in the Bay Area and at the university where I am, a lot of us are becoming multi-generational homes. So a lot of like my colleagues, a lot of my family members now, you know, it's like the grandparents and the parents and the children, and the grandparents are a huge critical component of it. They're actually part of even the child, you know, sort of development. And so I think we're going to have to just reimagine a little bit how we interact across generations. The more, you know, the older population is so important, I think. And for us, we would not be able to work here the way that we do if it weren't for the fact that we have, you know, 3 generations in one house.
One final comment.
Getting back to Richard's first comment, I think if you have to retire, I mean, many countries still have mandatory retirement. I say if you retire from something, make sure you retire to something else. It could be volunteer work, community organizing, political work, mentoring, tutoring, anything that gives you a reason to get up in the morning and a demand that you actually face with and interact with other people, particularly, as Susan was saying, people who are new to you.
Great, fantastic. Well, being respectful of everyone's time, I'm going to call a halt at this point. Susan, Saul, Dan, thank you so much. We could have gone on for another hour, and perhaps we'll revisit the topic again in the not too distant future. Just to let everyone know that we have another event on the 26th of April. It will be about wearable devices and the health values of those devices. So please join us for that. You can find out more information about Knowable. This event will be available on the Knowable website, along with a lot of other supportive materials. We would love to hear from you. We'd love your suggestions and your feedback. And please join us again for future events. Once more, thanks so much to our panel of experts for such an engaging and really valuable hour. And look forward to seeing everyone again at a future event. Enjoy the rest of your day.